Happy Thursday! So we're almost done with our second week of online learning. So today is a follow-up from yesterday's notes, and today you'll actually have an assignment that I'm going to link where you'll have to put into practice all the things that we've been talking about and taking notes on. I also will attach a link to a YouTube video that explains this as well. I know sometimes it's easier to understand when someone says it differently. So sometimes just having it worded differently or watching someone else do it can make things click. So I have added that as well. But for today's notes, you'll have two different pages that you're writing down. Again, I will attach these pictures if you'd like to print them. But I would prefer it if you wrote them along with me while watching this video, and feel free to pause whenever you need to write things down if I'm moving too fast. So the first page I've already got written, and it's super easy stuff here. And then the second page I'm going to write with you so you can watch me do some examples. But first we're talking about adding and subtracting polynomials. This is basically simplifying polynomials. So if we looked at some examples from yesterday, I showed you guys down here, you need to make sure that if there's anything that has the same power, that you're combining it before you actually label what type of polynomial it is. So when we're adding and subtracting them, you want to write it in standard form. You want to go from your highest exponent down to your lowest. And then you want to either add things together if it says it wants you to find the sum of two polynomials, or you want to subtract them if it says it wants you to find the difference. If there's distribution that's happening where you have a number in front of your parentheses, make sure that you're distributing to get that simplified, and then just combine your like terms based on the power. So I've written three examples. The first example, it says to find the sum of. So I know that we're going to be adding. So when I wrote it down here, I wrote this polynomial right here, and I added the second polynomial right here. So I have this entire polynomial written out, and now I'm just going to start simplifying. So I look at my highest power of 2. So I have 1x to the second power, and then I have 2x to the second power. So if I combine 1 and 2, it's 3. So we have 3x to the second, because we're adding. And then I look at just my x's, and I have 5 and negative 11. So I'm going to find the difference between the two, and it's 6. They're 6 apart, and you just keep the sign of the largest number. You can also think of it as 11 minus 5, which gets me to 6, and then keep that negative sign. Everyone does it differently. You can also think of a number line. You're at negative 11, and you go up 5 closer to 0. So you're actually going down in the number value as you get closer to 0. See, so that's why in my head I kind of do 11 minus 5, and I get 6, and then I keep the sign of the larger number. So anytime the signs are different, you're looking for the difference between the two. And then the only thing you have left are your constant, which is a 9 and a negative 4. Again, the signs are different, so what's the difference in 9 and 4? 5, and you're just going to keep the sign of the bigger number. So this would be my simplified answer when I added all of these values up. So you can write that down, pause the video if you need to. The second one is asking me to find the difference of this polynomial and this polynomial. So when I write them out, I put minus all of this. And so when I distribute, because I've got to get this 2 distributed to everything in that second set of parentheses, I wrote down here what the actual answer was. So negative 2 times positive 2 is negative 4. We know anytime they're not the same sign, it's always negative. Negative 2 times negative 11 becomes positive 22, and then negative 2 and 9 is negative 18. Keep the x values with your numbers that you're multiplying, and then at this point, we're just going to combine like terms. So I see my highest power is 2. I've got an imaginary 1 right here, and a negative 4. So 1 minus 4 is 3, or what's the difference between 4 and 1? 3, and you keep the sign of the larger number. 5 and 22 becomes 27, and you keep the x, and then I've got 4 and negative 18. Different signs. What's the difference between 18 and 4? 14. So we keep the sign of the larger number, negative 14. And then the last one, I just found an error in my answer. I need to go from highest power to lowest, so I'll rewrite it over here. But there was nothing in parentheses. It was just all written out, but we have multiple letters now. So again, they have to be like terms. So I look for my highest power and I see a squared. So I see a 6x squared and another 6x squared. So I combined those and got 12x squared. And then I just moved to the right as I was reading, and I saw two values that had an x and a y with them. So I combined -7 and +2 and got -5xy. And then I was just left with the 4y squared. There was nothing else to combine it with. But when you write this, you want to go from highest power to lowest. So I should have wrote the 12x squared plus 4y squared minus 5xy, going from my highest exponents down to my single. And again, these have an exponent of 1 right there, right? We just don't ever write those because they're not necessary. All right, so that is adding and subtracting polynomials. It's combining your like terms based on the power that goes with those variables. Now we're going to look at multiplying them, and we're going to do this example, all of these examples in this page together. So I'm going to flip over, and we're going to look at multiplying polynomials. So a lot of you have probably used the box method, which is totally fine if you want to use that. It takes up a lot of space on my paper. So in my notes, I typically always use FOIL, but I will do one example at some point with the box method if that helps you guys. So, and there's no wrong or right way. If you want a box method every time, please feel free. So when you're multiplying polynomials, you're either going to have just one single number that's multiplied to multiple terms, or you're going to have multiple terms multiplied by multiple terms. And that's where the FOIL or box method can come in handy. So let's do some examples. Let's just jump right in. So the first example I'm going to do will be distributing. So we have, let's say 8x times 2x squared plus 4. This is where those exponent rules come in handy. We took notes on them, but to refresh your memory, when you're multiplying, you add exponents. Okay? So 8, and you just multiply the coefficients. I'm sorry. So 8x times 2x squared. The 8 and the 2 give me 16. And then I can just, this is an imaginary 1 right here. I can just add those together and I get x to the third plus 8x times 4. I multiply the coefficients, which is 8 times 4. Okay, and then I just keep that x with it. It's 36x. And that's it. I can't combine these because this is x to the third and this is just x. They're not like terms. So that would be my final answer. So remember, when you're multiplying, you add exponents together if they have the same base. Because we were using x for all of those, I can combine my x's. Let's do another one. Three n squared times 6n plus 7. Okay, so I'm going to multiply, just distributing. Again, when you have one thing times multiple, you just distribute. It goes to everything in the parentheses. Okay, so what is 3 times 6 is 18. They both have an n, and I'm just going to add the exponents. This is 2, and this is an imaginary 1. So that would be n to the third, plus 3 times 7 is 21, and keep that n squared. Now let's do one that's got more to it, a little more oomph to our problem here. Let's do 3x plus 4 times 2x minus 3. Okay, so now we have multiple terms in both sets of parentheses here. And this is where some of you guys start to freak out and you're like, I don't even know what's supposed to happen. Well, FOIL is a good, acronym to remember to help you start. Multiply the first numbers together. So this is the first number in this parenthesis. This is the first one in this parenthesis. So you multiply your first numbers, then your outsides, then your insides, and then the last. So these are both the last number in those parentheses. So FOIL helps me remember. But you can also just, in this first set of parentheses, start with the first number, distribute it to everything in the back parenthesis until you're done, then move on to the next number and distribute it to everything in the back set of parentheses. So when you get some parentheses that have more than just first, outside, inside, last, and you've got tons of terms, just think of it as distributing a lot. Distributing the first term to everything back here. Distributing the second term to everything back here. And so on and so forth. And we'll do that in a second as well. So I'm going to use green because I've got a lot of arrows happening. So this number I'm going to multiply to the first number over here. First to first. 3x times 2x. Well, 3 times 2 is 6. And I'm going to add those exponents. There's an imaginary 1 here and an imaginary 1 here, which gives me x to the second. And then my outside numbers. So these are my two outside numbers. So 3x times negative 3 becomes negative 9x. Multiply your coefficients, keep that x. Okay, and then now insides, first, outside, these are my two inside numbers. 4 times 2 is 8x. I didn't circle that plus, but it goes with that 4. That's a positive 4, I'm sorry. And positive 4 times negative 3 is negative 12. So now all you have to do is say, all right, I've got some like terms here, and they're right here. Do you see how both of these have one single x? That means they're both talking about the same thing. This is negative 9x, and this is positive 8x. So when I combine those coefficients, it's negative 1, right? Negative 9 and positive 8 gives me negative 1. So my final answer will be 6x squared minus x minus 12. We don't ever typically write that 1. And I feel like I've said this a bunch here lately, but there's imaginary ones everywhere. And we don't ever really write them because it's redundant. Okay, so I just distributed this first number to everything in the back, and the second number to everything in the back. And then I combine my like terms. Let me show you over here to the side how you can box method this if you would like. So you'll just write the first parentheses in its own two boxes. So 3x gets a box and positive 4 gets a box. And then on the top, 2x gets a box and minus 3 gets a box. So you're basically turning it into boxes to write your answers instead of using arrows to figure out where we're working with. So I'm going to multiply 3x times 2x and 3x times negative 3. So 3x times 2x is 6x squared, and 3x times negative 3 is negative 9x. Then 4 times 2x is 8x, and negative 3 times 4 is negative 12. And then you just combine diagonally. So these two are like terms, and you can combine them. So your actual answer would be 6x squared minus x minus 12. Right? So when you actually write it out, you write diagonally. This first box usually doesn't have any like terms with it. Just check. Sometimes when you have large polynomials, you never know. And then you see, do any of these combine? And they do. They're the same terms, so we simplify that. And then there's nothing else to combine with negative 12. So you can either FOIL or box method. And as you can see, we got the same answer both times. You can put the imaginary negative 1 right here. It's the exact same answer. So I'm going to box this answer in. Then I'm going to do an even bigger polynomial. We've got 4x plus 2 multiplied by x squared plus 4x minus 4. Wow. So that's a lot. So that's going to be, we're not going to be able to do FOIL on this one because we have more than just first, outside, inside, last. We've got a lot happening back here. So we're going to think of it as distributing, but I'll also show you how to box method in just a second. So let's distribute this first term to everything in the back. So what is 4x times x squared? Well, we multiply our coefficients. What is 4 times this imaginary 1? It's 4. And then we add our exponents together for our x's. So this x right here has an imaginary 1 with it, and this has to the power of 2, which gives us to the power of 3. And then we have 4x times 4x, which gives me 4 times 4 is 16. We've got our x, and we've got to combine our exponents. This has an imaginary 1, and this has an imaginary 1, making it 2. And then 4x times negative 4. Well, we can just multiply those numbers together, and we get negative 16. And just keep that x that you had right here and bring it down. Now let's move on to the second number in our first set of parentheses, positive 2. Let's multiply the positive 2 by the x squared. 2 times this imaginary 1 is just 2, and then your x squared comes with you. So we have plus 2x squared. And then 2 times 4x, well, 2 times 4 is 8, and then you keep the x, so positive 8x. And then 2 times negative 4 is negative 8. Remember, when they don't have like terms, your answers are, when they don't have like symbols, your answer is always negative. If they're not alike, it's not good, so think negative. If they are alike, it is good, which means it's positive. So if they're both negative and they are alike in their positive or negative symbols, then it's positive. 2 negatives is a positive. 2 positives is a positive. It's good when they're the same. The only time it's negative is when they're not the same. So now we have this, which is our simplified version. We've just got to combine like terms. So our final answer, I'm going to go from highest exponent down. This is my highest exponent. It's 4x to the third. And then I have, here's 16x squared, but here's also 2x squared. So I can combine those. So 16 and 2 gives me 18x squared. Now I have just x's. So negative 16x and positive 8x. I need to find the difference between the two because they have different signs. So the difference is 8, and I keep the sign of the bigger number. So minus 8x. And then I have just a number, minus 8. So that would be my answer, which looks like it's a cubic polynomial. Okay. Now I'm going to do one more, and I want it to be kind of harder, but I want this to be in your notebook for you to refer back to. Okay, for your last example, write down, actually skip a line so we have some room. 6x plus 3y. Uh-oh, tricky, tricky. We're working with two different variables, times 6x squared minus 7xy plus 4y squared. Woo! Okay, so we can do it. So let's take this first term and multiply it to everything back here. We're just going to distribute one at a time. So what is 6x times 6x squared? Well, multiply your coefficients. 6 times 6 is 36. Bring down that variable and add your exponents. Remember, there's an imaginary 1 here. 1 plus 2 is 3. And then 6x times 7xy, multiply your coefficients. 6 and negative 7 is negative 42. This x and this x, 1 plus 1 gives me 2, so I have x to the second power. And I only have one y, so we're just going to keep that y there. And then 6x times 4y to the second is positive, what's 6 times 4? 24. And I can't combine my x with any other x because it's just a y. So I just have to write this down. X, y to the second. All right, that's it for the first term. Now let's move on to this second term, positive 3y, and distribute it to everything back here. Positive 3y times 6x squared. We have 3 times 6 is positive 18. And we can't combine anything, so it's just going to be x squared y, because you can't combine x's and y's, so all you can do is just bring them down and rewrite. 3y times negative 7xy, so let's multiply 3 times negative 7 is negative 21. I have one x and two y's, so that would be x y squared, right? I can combine this y and this y, which gives me y to the second, and I just have one x. And then the last one is 3y times 4y squared. 3 and 4 is 12 when we multiply that. And this is y to the first, and this is y to the second, which gives me y to the third. And now we combine like terms. So let's take a look. The highest exponent I see is 3 here and here. So let's write those first. 36x to the third plus 12y to the third. Can't combine them because it's different letters. Otherwise, I would be able to add these numbers together and keep that exponent, but this is talking about x's, this is talking about y's. Now let's look at 2's. I see a lot of 2's. This one has a squared, this one has a squared, this one has a squared, and this one has a squared, but I need to make sure that they're similar. So if you look, this is x squared y, and this one is also x squared y. So I can literally combine those two numbers. So what is negative 42 plus 18? You can plug that in a calculator, or remember, if they have different signs, we're looking for the difference, which means subtraction. So 42 minus 18 is 24, and I'm going to keep the sign of the larger number. So negative 24 x squared y. And now let's look at these. These both have x y squared. So these are like terms too. So I can combine this one with this one. So if I have positive 24 minus 21, my answer is going to be, what's the difference in these two numbers? And I keep the sign of the larger number. 3, right? 21 is 3 away from 24. 3 xy squared, keep those variables. And then, is that it? That's it. It looks like I've got them all. I wrote these two out at the front. I combined these two and these two. So I should have my final simplified answer, which to me looks like a 1, 2, 3, 4, a cubic polynomial. And that's how you multiply your polynomials. Again, if you need to box method, you can. you just write each term in the paragraph, you give it its own, in the first set of parentheses, not paragraph, I'm sorry, in the first set of parentheses, you give it its own box going down. In the second set, you give it its own box going across. And so I'll set this one up as a box and show you how you can do that too. So this one would be 4x and then 2, positive 2. They get their own box. Okay, so they each get their own little row here. And then the second part goes on the top. X squared, 4x, negative 4. And they get their own box too. So at this rate, you just multiply each one of these numbers by everything. So 4x times x squared, 4x times 4, 4x times negative 4, 2 times x squared, 2 times 4x, and 2 times negative 4. And then you just combine diagonally, right? And it's exactly what we did here. So you'd have, I'm going to run through this one real quick. You'd have 4x to the third, 16x squared, negative 16x, and then 2x squared, 8x, and negative 8. And so when you look, you can combine these two because they both have squared, and you can combine these two because they both have just an x, and you'll get your answer, which we saw was 4x to the third. And then when you combine these two, you get 18x squared. When you combine these two, because that's a negative 16x and a positive 8x, you actually get negative 8x, and then you just already have a negative 8. So as you can see, move this pen, it's the exact same thing. So you can choose the box method if you want, or you can choose to distribute or FOIL. And so that is how you multiply polynomials. And I will give you guys an assignment that will be uploaded as well with this video. I know that was long, but I'm really thankful that you guys watched it, and I hope that that was helpful.